Welcome to this VLSI design lecture series. In today's lecture video, I'll be discussing about 4-bit cross 4-bit NOR based ROM array, read-only memory array. So this is a circuit diagram of read-only memory. An example which we have considered here is 4x4 NOR based ROM array. It consists of 4 p-channel MOSFET whose gate input is always connected to logic level 0. So when the gate input of this PMOS is always connected to logic level 0, because PMOS transistor is turned on when its gate input is at logic level 0, always this P1, P2, P3 and P4 MOSFETs are always on. And when the P-channel MOSFETs are on, it acts as a closed switch. When the P-channel MOSFET is on, the source terminal is connected to, or the source terminal, whatever is present, it is connected to the drain. VDD is connected to the source of this P-channel MOSFET. It will be connected to the drain terminal of P-channel MOSFET. So VDD will be present in this entire column 1, column 2, column 3 and column 4. Initially, when all these R1, R2, R3 and R4 lines are 0, C1, C2, C3 and C4 will be equal to 1 because PMOS transistors are always on. Whereas, depending upon the row inputs which we are giving, R1, R2, R3 and R4, C1, C2, C3 and C4 will be changed. Column lines will be changed. Depending upon the row lines, whatever we are giving, the column lines will change. And that will be changed because these row lines are connected to N-channel MOSFETs. If we observe here, we have considered 8 N-channel MOSFETs. These 8 N-channel MOSFETs, the source terminal is connected to the column line and the drain terminal is connected to ground. So when these N-channel MOSFETs are on, the column lines, those specific column lines will be connected to ground. So we can understand how this works in detail by making use of the truth table. Now, let us consider the first case. When row input is 0, R1 is 0, R2 is 0, R3 is 0, as well as R4 is 0. So when all the 4 row inputs is equal to 0, N1 MOSFET, N2 MOSFET, N3 MOSFET, N4, N5, N6, N7 and N8, all these 8 N-channel MOSFETs are off. The reason is all these N-channel MOSFETs are connected to logic level 0. N-channel MOSFET turns on when the gate input of it is connected to logic level high. When the gate input of this N-channel MOSFET is connected to logic level 0, it is under off condition. Under off condition, it acts as open switch. Open switch in sense, there is no definite connection between the source terminal and the drain terminal of the MOSFET. Whereas, if we observe P1, P2, P3 and P4, 4 PMOS transistors, it will always be on. The reason is the gate terminal of P1, P2, P3 and P4 is always connected to ground. This P-channel MOSFET turns on when its gate input is at logic level 0. So always these P-channel MOSFETs are on. And because all these N-channel MOSFETs are off, all these N-channel MOSFETs act as open switch. When it acts as open switch, there is no definite connection between the source terminal of the MOSFET to the drain terminal of MOSFETs. And hence, because the drain terminal of the MOSFET is connected to ground, none of these column lines, now it is connected to ground. Hence, all the column lines is connected to VDD. So when the column lines are connected to VDD, VDD logic level is logic level 1. So all the column lines, the output will be equal to logic level high. So this is the first case. In the second case, let us consider second case here. In second case, when R1 is equal to 1, column 2 should be high and column 4 should be high, whereas column 1 and column 3 output should be low. Let us check how we get that. Now, for the second case, when R1 input is high. So when R1 input is high, R2, R3 and R4 is 0. R1 input is high, and because of that, N1 MOSFET gate input is connected to R1 as well as N2 MOSFET gate input is connected to R1. So N1 MOSFET and N2 MOSFET will be on, whereas N3, N4, N5, N6, N7 and N8 MOSFETs are connected to logic level 0. Gate input is connected to logic level 0. Hence, N3 to N8 MOSFETs will be off. So when N-channel MOSFET is on, it acts as a closed switch. Whereas when N-channel MOSFET is off, it acts as open switch. Because N1 and N2 act as a closed switch, there is a connection established between the column line 1 to ground. Similarly, column line 3 to ground. And because of that, column 1 becomes equal to 0. Column 3 also becomes equal to 0 because it is connected to ground. Whereas column 2 and column 4 is not connected to ground. Hence, column 2 and column 4 will be equal to 1 and 1. So first truth table is satisfied. This is how the column data is reflected based on the inputs which we have given to the row. Similarly, let us consider one more condition. When R2 is high, let us consider R1 input is 0, R2 is 1, R3 is 0, and R4 is 0. So when this happens, because N3 MOSFET and N4 MOSFET is always connected to R2, and R2 input nowadays equal to 1, N3 and N4 is on. Whereas apart from N3 and N4, N1, N2, N5, N6, N7, N8 are off because the gate inputs of N1, N2, N5, N6, N7, N8 are connected to logic level 0. Hence, those MOSFETs are off. If we observe here, only MOSFET number 3 and MOSFET number 4 are on. Hence, C1, there is a provision of C1 connecting to ground. Similarly, C2 is also connected to ground. Column line 1 and column line 2 is connected to ground. Hence, the output of this C1 and C2 will be 0. Whereas C3 and C4, the output will be equal to 1 because the column line is not connected to ground anywhere. Hence, when R2 is equal to high, C1 and C2 will be equal to 0, whereas C3 and C4 will be equal to high. Similarly, let us consider third case. When R1 is 0, R2 is 0. Now let us consider R3 is 1 and R4 is 0. So when this happens, N5 and N6 MOSFETs are connected to logic level high. Gate input is connected to logic level high. So when the gate terminal of this N5 and N6 is connected to logic level high, N5 MOSFET and N6 MOSFET is on, whereas N1, N2, N3, N4, N7, N8, the gate inputs are connected to logic level 0. So those MOSFETs are off. When the MOSFET is on, it acts as a closed switch. When the MOSFET is off, it acts as a open switch. So because N5 and N6 MOSFETs are on, C2 column is connected to ground as well as C3 column is also connected to ground. Hence, C2 and C3 will be at logic level 0, whereas C4 and C1 will be at logic level high because C1 and C4 doesn't have the connection which is connected to ground. Similarly, let us consider the last case. When R1 is 0, R2 is 0, R3 is 0, and R4 is 1. So when R4 value is 1, N7 MOSFET and N8 MOSFET, the gate input of N7 and N8 is connected to R4 whose logic level is 1. So N7 MOSFET is on and N8 MOSFET is on, whereas N1, N2, N3, N4, N5, N6 MOSFETs, the gate input is connected to 0. So all those MOSFETs are off. When MOSFETs are off, it acts as open switch. If MOSFETs are on, it acts as a closed switch. So because MOSFETs are on, N7 and N8 MOSFETs are on, C1 line is connected to ground and C4 line is connected to ground as well. Hence, C1 output will be equal to 0, C4 output will be equal to 0. Whereas C2 and C3, because it is not connected to ground, C2 and C3 will be equal to logic level high. So when R4 is equal to 1, C1 is 0, C2 is 1, C3 is 1, and C4 is 0. So depending upon the inputs which we are giving here, row inputs which we are giving here, the column data will be decided. I hope that you have understood this video lecture. Thank you.